Welcome to Spotlight on Climate. Welcome, Dr. Sommer, to the show. Get as close to that mic as you feel comfortable, and we'll start. Welcome to the show.
Well, thank you very much, Talyne. Thank you very much for having me on the show. I understand this is the very first episode of the show?
This is the very first episode of the show, and quite excited about it.
I think it will be a wonderful show for helping people to understand what's going on with climate change, why it's an important topic, not only the scientific understanding of it, but also what are some of the consequences and what are some of the solutions. We know what we need to do. So we'll talk about those things and hopefully talk about how to get people to implement them.
Oh, that would be the best part, right?
Right, the most important part.
Exactly. Well, so why do we need to do this show? Let's start with that. People talk about it, but in many places I find that it's become just rhetoric. Just people saying, oh, we need to do something about this without committing to action. There are real concerns and real things happening that I think are important to point out to people, because then they're just not talking with an empty voice, basically.
Well, there's so much going on globally with climate change now, and the other side of it is we've got the scientific understanding about climate change, but also, of course, the fossil fuel industry is worried about its own future, and for decades they've been putting out misinformation about the relationship between fossil fuels and climate change. And so against that backdrop of misinformation, it's harder for scientists to get their understanding out to the public. There's no question, though, the data are clear. We have already raised the Earth's average temperature, and this is global annual average temperature, by 1.3 degrees centigrade.
That's actually nearing the tipping point, right?
Well, so yeah, we've been talking for a while now about 1.5 degrees centigrade is a time when many much worse things will be beginning to happen, and we should avoid reaching 1.5 degrees centigrade warming. But at this moment, we have already put over 2,500 gigatons of CO2 equivalent into the atmosphere by burning fossil fuels primarily, but also cement production and some of our agricultural practices and burning forests and so forth. All of those contribute CO2 to the atmosphere. So we put 2,500 gigatons into the atmosphere already. When we reach 2,900 gigatons, that's almost 3 trillion tons, we will reach 1.5 degrees centigrade warming. And that doesn't sound like a lot, right? 1.5 degrees. But you got to consider, that's raising the temperature of the entire Earth's atmosphere, the entire surface of the land on Earth, and the entire surface of the oceans by 1.5 degrees centigrade. Just imagine how much energy that is.
The thing that made it really clear to me how much that number meant and how much of a difference it can mean is the 32 degree mark. If it's 33 degrees, it's raining. If it's 32 degrees or 31 degrees, it's snowing. And so that 1 degree makes an entire difference in how the weather is going to affect you.
Certainly. Yeah, the boundary at different temperatures can have a huge effect on what's happening with our weather.
It makes it more understandable to me.
Yeah, and what we're talking here, though, is we have raised, all of that volume, the entire atmosphere and the entire surface of the Earth by that much. And that's not just a, 1 moment measurement. That's the average across a whole year. So there's a lot of variation in temperature. And so, again, that variation makes it hard to understand that 1.3 degrees centigrade is huge. Because it changes moment to moment when we're out having our beautiful day in the park or whatever. But what we're talking here is 1.3 degrees centigrade warmer on average across the entire year and through the entire volume of the atmosphere and surface of the Earth. So Would 1.3 degrees centigrade in that context is just massive.
And we're talking here about climate, not weather.
Yeah.
So could you take a moment and talk about the difference between weather and climate? Because a lot of people say, oh, the weather, it's snowing. How can there be climate change? How can the earth be warming if it's snowing outside? Or that kind of thing.
Yeah, so weather is what we experience every day. We wake up and it's a certain temperature and we dress accordingly and we go out. And we expect, though, that generally, because we have our seasonal climate shifts in Flagstaff, we know when our summer temperatures occur, when our fall and spring temperatures occur, and when we're going to have winter and snow and so forth. So different parts of the globe have different climates. They have their seasons slightly shifted relative to each other and different long-term patterns of when it's hot and cold and wet and dry and all those different things. That's climate. Over the long term, we see patterns in the weather, and we call that climate. So weather is the daily stuff. Climate is the long-term stuff. And so when we talk about changing the climate of the earth, again, that's just so much bigger than talking about the shift in the weather. We're talking about things like, I don't know if you all remember just a couple of years ago, we had, because temperatures are warming at the lower latitudes, the temperature differential as we go from the lower latitudes up into the Arctic Circle, the temperature differential isn't as large anymore. And so we've weakened the jet stream. And because the jet stream is weakened, it wobbles, and so it undulates north to south. And so a few years ago, y'all might remember freezing rain and freezing temperatures for a long period down in Texas, of all places, because we had this southward leaning undulation of the polar vortex, and the infrastructure in Texas just couldn't deal with it. So, the grid system broke down, all sorts of things. They were not prepared because their technology was set for the kinds of temperatures their climate is used to. Now we're getting whole new patterns because we're rearranging the polar vortex, the jet stream. We've also seen what we call atmospheric rivers, and that's become part of our day-to-day language.
And that's what caused the tremendous rain and flooding in California.
It has caused a lot of rain and flooding in California over the years. So when we're talking about warming up the average temperature of the Earth by 1.3 degrees centigrade, what that's doing, basically, it's putting more heat energy into the whole climate system. And so the climate system has that much more power, that much more heat power to drive droughts, to drive storms, to drive monsoon downpours. All of these things are getting more intense and more frequent.
And so when more intense storms means climate is actually making that storm worse.
Absolutely.
More frequent.
Absolutely. And for a while, people were wondering, can we blame a particular storm on climate change? And it doesn't really work that way, but certainly we can look at the frequency of storms and the intensity of storms over time, and there's no question that the increase in intensity of storms and the increase in frequency of storms are both caused by human-caused climate change.
And that data is collected, it's a pattern. It's over the years that people are looking at that, not like you were saying, the weather is something that happens every day, but this data about storms being more intense is something that was collected over a period of time, correct?
Oh, yeah. So we study climate across all kinds of different time periods. We can look over the last 100 years. We can look over the last 100,000 years. And there are different ways to look at those records. So I don't know if you're familiar, but a lot of the climate science that helps us understand how things have changed over time were discovered here in Flagstaff. So there was a fellow who worked here back in the late 1800s. He worked at Lowell Observatory. His name was A.E. Douglas, and he was interested. He was actually an astronomer. And at the time, they were building a city, Flagstaff, and there were a lot of tree stumps. And he was sitting there looking at these trees, and there are all these tree rings. And he thought, wow, maybe I could look at the long-term records of sunspot cycles by looking at the changing widths of these growth rings. It turns out that yes, he could, but what he found as he was looking at this, there was a much stronger connection between the width of those growth rings and rainfall. And so by making that observation and publishing his data, he founded the field of dendrochronology from little old Lowell Observatory here in Flagstaff. And that field has allowed us to analyze tree ring widths and growth patterns back thousands of years, back 11,000 years, and in some cases even longer. And so that gives us a very solid idea of what rainfall patterns were in the past. And from knowing that, we can see that our current rainfall patterns are changing and that they're different. Without that baseline, we wouldn't know that they were different.
Exactly. One of the things I found fascinating about that information was kind of an offshoot. That is the entire climate system of the trees, of the astronomy, all of it is part of a puzzle. And without one piece of it, it doesn't seem like you get the whole picture. And so I found it fascinating that this astronomer founded something, that was of interest to him via tree rings. And so that's an arborologist, and this is an astronomer, so it's kind of like the ankle bone being connected to the shoulder bone.
Yeah, well, and scientists are trained to be careful observers of patterns in nature and different phenomenon. And so it's not that infrequent that a scientist in one field will discover something in another field or discover something that founds a whole new field, as in the case of A.E. Douglas founding the field of dendrochronology
Right.
by looking at tree rings that he was trying to analyze for sunspot cycles. So not only are those patterns related in nature in different ways, but scientists are trained to be careful observers, and so they often discover things that they hadn't really even anticipated.
Which is a lot of why it's the reason why we come up with new discoveries, medical discoveries, inventing the wheel, basically. You can go all the way back.
Well, yeah, so to go back to the beginning of this particular suite of understandings, really we've known about climate change and the greenhouse effect since Joseph Fourier first proposed it in 1824. He first published his results in 1824.
In 1824?
1824. So we've known about this for a very long time. And basically his observations were that he did some quick, calculations, hand calculations. If we are such and such a distance from the sun, we get so and so much radiation, solar radiation, sunlight from the sun, it should warm the earth to about this temperature. But in fact, the earth's temperature is higher than what you'd expect based on just that. And so he proposed that there was something in our atmosphere that was holding in that heat energy. And he proposed that there were gases, likely, that were holding in that heat energy. And then, so that was 1824.
That's
Then
200 years ago.
that's a long time ago. And then in 1854, American scientist Eunice Foote first quantified the relationship between CO2 and the amount of infrared radiation that it absorbs. So we know about the greenhouse effect from Joseph Fourier's initial calculations, and we know that CO2 is a greenhouse gas from Eunice Foote's calculations and observations in 1854. And then by the end of the century, in 1896, Svante Arrhenius was putting those two things together and starting to make some calculations on, well, if we have added this much CO2 to the atmosphere, how much will that increase the Earth's temperature? And he came up with this rule in his calculations. He called it Stefan's rule, so I like it a lot. And basically, it shows the relationship between greenhouse gas CO2 concentration and the Earth's temperature. And it's not really surprising that those things are related. We hadn't thought about it until these people made their careful observations. But when you go out in the sun, what do you notice first thing? It makes you warm, right? You get a tan and everything too, but first of all, it makes you warm to be in the sun. And so all that incoming sunlight is what gives the Earth its warmth. We also know from sleeping on a cold night that if we have a blanket, it holds in our heat closer to our bodies. Now, what Eunice Foote discovered And what Arrhenius Svante first quantified was the relationship between that CO2 in the atmosphere being the blanket that holds in that heat that we
That's a
get from the
very
sun.
good analogy.
So the sun heats up things on the earth, and then the greenhouse gases hold that heat in, keep it from just reflecting back into outer space. And so as we put more greenhouse gases into the atmosphere, it's like thickening the blanket. We hold in more heat and we stay warmer.
And it makes, when you explain it that way, it's easy to understand. It makes it easy to understand. And I think from my observation, I've found that many people thought it was too complicated to understand or didn't bother to try and understand. And it's really very simple. We're just making the blanket thicker.
We're thickening that blanket of greenhouse gases. And so, overall, we're very happy that the Earth has a greenhouse effect, because without it, life as we know it wouldn't be possible, because most water most of the time would be frozen. Because we've got a greenhouse effect, the Earth stays within a certain temperature range that's ideal for life as we know it. Now, though, we're thickening that blanket and holding in more heat, and we're doing it at an unprecedented rate. We've had shifts in CO2 concentration in the Earth's history, and we can go back hundreds of thousands and even millions of years by looking at different records of how that CO2 concentration has changed over time and what the Earth's temperature has been across that same time period.
And I go back to the words you said, life as we know it, because I've encountered conversations where people would say, oh, we can't hurt the Earth. And maybe that's true. Maybe Earth will bounce back and shake us off. But the point being, it's going to shake us off. And we like living here, right?
Yeah.
So life as we know it can't be accommodated with the projection of climate change that, as it is right now. If we keep going this direction, it will not support mammalian life.
Mammalian life, yeah. So you're absolutely right, Talyne. And there have been some periods in the Earth's history where we had CO2 concentrations go up, either through massive volcanic activity or other things like asteroid impacts that caused large sections of the Earth to burn, changed the greenhouse gas concentration, caused global warming, not nearly as rapidly as we are causing right now, but as a consequence, we've had 5 mass extinctions through the Earth's geologic history. And in many of those, we lost anywhere from 75 to 95% of all species on Earth. Think about that. If we put ourselves in just a couple hundred years into that kind of a situation where we're losing that proportion of the Earth's species over that short a time, we're going to, as large mammals, we will struggle to survive. We've got all kinds of adaptations that might help us get through, but our life support systems are going to be undermined completely, and our chances of survival are really very low.
And it doesn't seem like the technology exists to, like you were saying, we have different technology that can help us through this period. I don't think it can last forever, can it?
Well, it can.
There's no technology for it to last forever, right?
If we wipe out marine and land terrestrial species to that extent, our life support systems will be gone. In any case, rather than speculate about all of that, though, I mean, we know that if we go in the direction that we're heading now, things will be very, very bad. But we already see the effects of climate change. It doesn't have to get that bad before it's a crisis, and it is already a global crisis.
And so this is the problem. What can we look forward to on the show to address this problem, address this crisis? What can we do? Is there anything for us to do?
Well, yeah, and so, we've seen the crisis in terms of all these more intense and more frequent hurricanes on the East Coast. That's a headline right at the moment, but also massive droughts and wildfires around the globe on every continent. Few years back, Siberia was burning, and it usually does not dry out enough to burn.
And that's the great forest of the north. I mean,
Right. So yes, there are some things we can do. So for one thing, we have a number of different guests coming on the show in the near future. John Fegverisi is a climate scientist here at NAU who studies ice cores in Antarctica. And so they've looked in very, very close detail. From the ice cores, we can get both temperature records, the Earth's average temperature at the time that ice was laid down, as well as in the little bubbles that are frozen into that ice, what the atmospheric composition was at that time. So we know the relationship between temperature and CO2 through those ice cores. That can inform us that, yes, we need to reduce our emissions. And then there are lots of technologies for helping us to do just that. We've got Dr. Tom Acker, who's a retired professor from NAU, he's actually not fully retired. He's retired as a professor, but he is now working for SRP because of his expertise in wind power. So he designs wind turbines, and he and his graduate students over the years installed wind turbines, including out at the Perrin Ranch wind power plant, just to the west of Flagstaff, just north of Williams. So he's now working for SRP, and he's going to be on to tell us about how they are implementing that renewable energy source so that we can replace fossil fuels with cleaner electricity. The beautiful thing right now around Flagstaff is that we have our business community is sort of at the forefront of this. They have been installing wind and solar power all around Flagstaff. We already have the 99 megawatt wind power plant out at Perrin Ranch, the 129 megawatt wind power plant at Dry Lake Hills. As we speak, Babbitt Ranches is putting in 161 megawatts of wind power and 80 megawatts of photovoltaic just north of the peaks. Next year, they're going to begin a much larger photovoltaic power plant that'll put out 480 megawatts. And they're putting in
a lot.
they're putting in gigawatt worth of battery storage. So not only will that be good generation, but it'll also power us day and night. As we speak, another group is putting in, also on Babbitt Ranch's land, out at Chevelon Butte, east of Winslow, southeast of Winslow, another 477 megawatts of wind power. So in short order, we will have 1,424 megawatts of clean electricity here. So the time to get away from old, ancient, cranky combustion technology is here. The time to shift to all electric is now.
And when I talk to people about that, I hear many people say that there's problems with this, with wind power, with solar, blah, blah, blah. And they concentrate and they name all the problems that were with it. And they may be right, they could be wrong, I don't know. But I do know this. Everything that works right now used to not work. It was invented. And so the inventor had to try how many times to make it work. Whatever it is, it wasn't in operation before it was created. It
Right.
through trials and tribulations. So are we going to address some of the problems that go along with, like lithium mining, for example, is the one that people are talking about?
That's a big one. So if you look at this, many of the different technologies are competing for theirs is the best. Tesla is now putting out information that suggests that fuel cell electric vehicles powered by hydrogen have this and that and the other problem, which is really a hype. In any case, the fossil fuel industry is supporting themselves. If you look at the lithium mining, there are definitely some bad issues, but they're not nearly as bad as all the combined metal mining that goes into combustion vehicles. So yes, we need to make our mining practices, in both cases, cleaner, less abusive of the workforce in the countries where those things are taking place. That said, we desperately need to stop global climate change because the kinds of negative effects that mining have on people pale in comparison to the kinds of effects that climate change is now putting on those same people.
And their livelihoods, they're where they live. They're more climate refugees now, obviously, than ever before.
Right. We know that there are negative effects of mining, not just lithium, but of all sorts, and we need to clean those up. The bigger effect right now is that farmers around the globe are experiencing climate change. If you look, we used to think of Iowa as the king of corn, right? Back in 2018, the Wall Street Journal had a front page article about corn production, and they pointed out that at that time, corn production in Iowa had become volatile. Some years were booms and other years were busts. While at the same time, corn production in northern Alberta, they spotlighted Lacrete, Alberta, which is north of Edmonton. There, corn production had been rising steadily for years, and it looked like it was going to continue, and certainly it has since then. So all of our agricultural systems are being pushed northward as temperatures in the south increase. People are affected by those temperatures too. Our housing market here in Flagstaff is affected by climate migrants who are escaping the heat in central Arizona. If they can afford it, they come up here and buy a second home, and that drives our old home prices up. If they can't afford a second home, oftentimes they'll escape for a week or a weekend. And that puts other pressures on our housing market because many people convert their houses into Airbnb and other short-term rental situations. And so less of our housing is available for local people to live in. So there's so many different things. And in some parts of the world, agriculture has been hammered by ever-increasing drought. And that's certainly the case for us here in the Southwest, but there's also an area in Central America referred to as the Northern Triangle. And it's large swaths of three countries, El Salvador, Guatemala, and Honduras. And they've been hammered by drought so that in the low elevations, they can no longer grow their corn, their beans, and their melons. And the mid elevations in those countries, there are whole new diseases. The seasonality of rainfall has changed and whole new plant diseases have come in. And so growing coffee is harder now in those mid-elevations. All of those people who are affected by that drought flee first to the cities. The cities don't have work for them, and so then they flee northward. When you look at the people arriving at our southern border, they come from all over the place. But the three countries that are most represented amongst all those refugees are Guatemala, Honduras, and El Salvador. Most of the refugees arriving at our southern border come from those three countries.
So we're going to address many of these issues, and like Dr. Sommer said, we're going to have guests that are experts in their field talking about what they see the problem as and what they see the solution to be. So anyway, tune in for Spotlight on Climate. Thank you very much for joining us, Dr. Sommer. And I love the blanket analogy that you made. It's easy to understand. And that, I think, is going to be really helpful to people. So say the website of the NASCA's website.
So yeah, we've got a number of really amazing guests coming on to the show in the near future. If you want to see the whole schedule, go to the Northern Arizona Climate Change Alliance website. That's www.nazcca.org. And you can look on the calendar of events or on the Spotlight on Climate radio show drop-down from the front page and see the whole schedule of upcoming speakers. And as these shows happen, we will be archiving them also in the same location, so you'll be able to listen to old shows that you may have missed. In any case, we've got great people coming up, not just Dr. Tom Acker and John Fegvaresi, but Dr. Tom Whittam, whose research here at NAU is about how do we adapt to the new temperatures and the new climate. And Brian Bates, who's retired science professor from Coconino Community College, and Zach Adams, who's a recent PhD in biology from Stanford, who has put together an institute to train people to educate people about climate change. So we have some really exciting guests coming on.
Yeah, thank you. Okay, well, tune in for that every Friday at 10:30. Join us right after Radio Sunnyside Roundup. And again, thank you for joining us, Dr. Sommer.
Thank you very much for having me on, Talyne.
You're welcome.
Spotlight on Climate is brought to you by the Northern Arizona Climate Change Alliance in conjunction with 101.5 FM Radio Sunnyside. Our host is Talyne Corlyn. This broadcast is produced by David Bull. Stefan Sommer serves as executive producer. For feedback to Spotlight on Climate, or to learn more about the Northern Arizona Climate Change Alliance, visit nazcca.org.